Okay, class, I hope you can see me in the whiteboard here because I'm having this class from PT2. Please tell me if you can't see or you cannot hear me, okay, and by typing message in the chat, okay? Because now I'm using mic connected to my laptop. I'm not able to hear you. If you on your mic and say something, I can't hear. So please use the chat. So I hope everyone can hear me. So now, today I'm not going to, I try to just take about 2 hours of your time because you still have your design project to complete. Now today I'm going to go through with you a few things that I have been able to pick up from the design project discussions, question being asked using design project to this studio session, as well as in the process of marking your test answer, some of the things that I would like to highlight to you so that you won't repeat the same mistake. Okay? Now, I think we should start now because although there are not too many students yet online. Okay. Now, the first thing that I would like to talk about is, I hope you can see. If you can't see, please let me know. I'll write a bit larger. Okay. So this is specifically about design of BIM class. Now, the first thing is, can you see? Can you see the writing? See, yeah. Can you see the writing, class? Are you able to see the writing? To adjust this. Can someone respond? I think if you can't see what I'm written on the whiteboard. Okay, so okay, thank you. Thank you. So the first thing is about the examination. So the first thing, class, I think what I discover is you have to read the questions. Okay, read the question. I think read the questions given to you, and then those that you want to answer. Of course, the first thing is to understand what the question wants. That is the important thing. And then the other important thing is after you read the question, use the data given. Use the data given, meaning that don't redo, because in exam, you have only 2 hours, you have 4 questions to answer, so you know the time that you have. So do not redo. If the cover already given, don't redo the process like what you have done in the design project, because what you have to present in your design project and our design report is different from when you need to give answer to tests or exam. Use the data given. Do not redo or recalculate data already given. Example, if cover is given, then use the cover given. Cover given 25 mm. Don't redo again, try to find the C norm because you will lose time. The second thing is, I'm referring to the test question I'm given to you. For example, it's already stated all the slabs are one-way slab. So no need to redo again Ly or Lx more than 2. This is one-way slab. Because it's already stated for you, the slabs are all categorized as one-way slab. So do not redo or recalculate information already given. This is because we know that the time allocated to you, that's average for questions, you know how much time that you can spend. So do not redo, okay? Do not redo or recalculate data or information already given. The second thing is, if the bar size already stated for you, do not use other bar size. Do not use other bar size for link or for the main reinforcement. Do not use other bar size, which is different from what is specified in the question. If it already even asks you to link pi diameter 8, use diameter 8. Do not use diameter 10. If already stated, use diameter 16 for the main tension reinforcement, use diameter 16. Do not use diameter 20 or diameter 12. Only those which are not given, you can assume. So do not use other, because if you use other means you do not follow instructions, and then meaning that you lose mark for that. Okay. So the other thing is, you do not have to rewrite again all the data given. In design project, when you present the design report, yes, we need you to write down all the design data that you use. But in the test or exam, you don't have to rewrite all the data which are already given to you, because all this a little bit here and there will take away your time. Your only job is answer the questions. Okay, answer the questions. So presenting your answer in a test and exam is different from presenting contents required in the design project. Okay, go straight to what the question asks. So if any question, please, I think you can ask straight. Okay. So that is the first thing. And now the second that I want to touch on is mistakes, the basic mistakes that you have made, and which I think shouldn't have happened. Okay, do not make those mistakes, because that will have serious implication on all the subsequent steps. Okay. Now the whiteboard is not very big, so I have to erase, but I recorded this. Later I will share this. So this is the first thing, class. If you have any questions, please type in the chat. I'll try to answer. The second thing is about mistakes. This mistakes class is not the, it's a basic mistake that you should avoid. Now, the first thing is, remember, I'm talking about beam. So loading on the beam, when finally you calculate, for calculation of shear force and bending moment, it must be in kilonewton per meter. So you must get that clear, because beam is one line, different from slab. This is one surface. So eventually when you calculate, it must be in kilonewton per meter. If you answer loading on slabs, you start with kilonewton per meter square. Okay, it must be kilonewton per meter. So I'm trying to indicate to you here some drawings. So if I have so if I want to look at this beam here, so the loading that I need to designed to determine acting on this. For example, if it is uniformly distributed for this particular beam, it must be in kilonewton per meter. Okay. And if other parts, if we have slab, our slab loading is given the slab loading. This is in kilonewton per meter square. And from this side and from the other side here. This is in kilonewton per meter square. So when you consider the loading from slab onto the beam, so finally you have to get the equivalent from kilonewton per meter square onto kilonewton per meter. So that process later on I'm going to elaborate again how the important things that you need to take note. So it has to be kilonewton per meter class. So sometimes some of you give the ultimate design load. The unit become kilonewton per meter square on the beam, which is completely not correct, the concept. So remember that thing. This time I will come back again specifically on taking loading because many of you are having problem taking loading on beam. Loading from slab transfer to the beam that eventually you need when you need to calculate the VED or MED. Okay. The second thing is class flexural reinforcement that for beam that you need to design for. Can you see this part here? If you can't see, please let me know, because the flexural reinforcement details when you, after you design, okay, for beam. It should be stated given as 3H12, for example, or 5H16 or 4H20, because this is beam. So within that width of the beam, we want to provide how many bars with the size, how many numbers. Okay. It is not, it should be like this and not H12-300, H16-250, or H20-200. This is not correct. This is not for beam. This is for slab. Yeah? For slab, because we are taking of 1 meter width. So within that 1 meter width, we want to distribute the bar size, the bar with H12, H16, H20 with the spacing of 300. But beam, so class, do not give answer in this way. This is basically wrong. Okay? Basically wrong. In this case, you use a wrong table. You have already used a wrong table in the design formula book to find the AS provided. AS provided, there are two tables that if you are aware of in your design formula book. One is for per meter width. That is when you design slab, when you design footing, yes. But when you design beam, there's another table. Okay, please get familiar with that, which is given to you how many group of bar give you that area. So the flexural reinforcement details for beam should be given in this way, class. Remember, don't give in this way. This is wrong. Completely, the concept is not correct. Okay? So that is about this. And another thing is, this is basic. Effective depth. Calculation of effective depth, you need it for your slab design as well as your beam design, and sometimes in column design when they have bending also. So when you design for beam, when you calculate effective depth, you must use the H for the beam. I have to erase now, class, but this one I'm recorded. So the next thing is effective depth. Effective depth is one very important calculation because you start flexural calculations by getting the effective depth to the tension reinforcement, effective depth to the compression reinforcement. For the calculation of D, which is the effective depth for beam, use the H for beam class. Okay. When you want to design for slab, when you want to calculate effective depth for slab, you use the H for slab. For example, D is H minus cover minus diameter of link. Then you can do minus diameter of the main bar, or half of it. Okay, if it is only one layer of bar that you arrange. So this D here, this H here is this H here. Okay. This is the H that we use to calculate the D for beam. Not this H. Not this H. This is for slab. Okay, so the one that you have to use it correctly, because for question for D beam is this. This is for slab. For slab, you need to also calculate effective depth. Then you use the one that is given for slab. So take note of that. Okay. Any questions you can raise any time. Okay. If not, then I will stop then for question time. Now the next thing is I'm going to talk about. But let me go through some of the mistakes that I pick up and then that I hope you can avoid. So this is about effective depth D. So effective depth, sometimes when you calculate, it becomes very small. You should suspect if your beam depth is 450, this D cannot be 120. Or cannot be very small. I mean, you have already used the wrong H. Okay. So the next thing that I would like to talk about is about the shear. When you do shear reinforcement. Well, we don't have to copy. This one is recorded. I just take out the main point. When design for shear reinforcement, which is the shear link, when designed for shear reinforcement, remember this theta, the inclinations of the strut, compressive strut in the model adopted in EC2, this theta has to be decided. We have to determine this. And we know that theta is in the range of 22 and less, between 22 and 45. This is for EC2 using the model adopted, okay, to represent shear action in the beam. Okay. So this one we do not know whether it's 22 or in between 22 and 45, but it cannot be more than 45. So what do we do is we have to trial. We try with theta 22 first, then we get with VRD max. If the VRD max that we calculate using theta 22 degree is already more than VED, that means theta is 22 or 21.8. We try this first, then if this is more than this, then theta 22, then no need. And there's no need to calculate theta again. You will spend extra time. No need to calculate theta. Because if this is more than that, theta already 22, then no need to go through these steps. If you go through this step, you spend extra time because the theta already 22 if this is more than this. When is this needed? Only when if VRD max theta 22 is less than VED, then theta will be more than 22, but We don't know how much. We don't know how much. So we have to use the equations to calculate theta. Okay. Then in this case, theta will be in between. It will be here. And what is the actual theta? And then use the equation to calculate theta. So in this case, you have to calculate theta. Maybe 23, 24, maybe 25. Okay. But if in this case, class, don't need to go through the process to calculate theta because you spend extra time and this is not needed. Only when VRD max less than VED, and of course, and VRD max theta 45 degree is more than VED, so we have to calculate theta. But if you find theta more than 45, then this one cannot use. Yeah? So this is about shear reinforcement. Now, another very, very basic things that I think I have tried to mention in class, but I think maybe the message is not clear enough is when you calculate self-weight. Okay? When you calculate self-weight, you need to make use of the unit weight of concrete. Unit weight of concrete is 25. It does not depend on FCK, nothing to do with FCK. In the calculation of permanent load, due to self-weight. The same thing for slab. The same thing for footing if you need later. The value of unit weight of concrete class is 25 kilonewton per meter cube. So if FCK given to you is 25, FCK 30, FCK 35, it doesn't matter whatever FCK given, the unit weight is 25. In the test, I asked you whether it's correct or not. It is incorrect. Because if you remember, I asked you whether the calculation is correct or not correct. It's incorrect because in the test, it is used the unit weight as 35. Okay? So pick up this important point. I think class, the unit weight in EC2 for concrete is 25. The unit is kilonewton per meter cube. So don't use 35, 30, 25. You might don't confuse with FCK. FCK, the unit is Newton per millimeter square. This 25 is kilonewton per meter cube. Now, the second one, which is I think also a mistake, is when we design continuous beam, we can use table. We can use table to calculate what is the design ultimate shear force and bending moment for different span. Okay, this I will come back again to that when I talk about loading on beam. But in order to I don't miss up that point, when you use, for example, when using, this is specific table 3.5. This is in the design formula book. This comes from BS 8110. To calculate ultimate bending moment and design shear force, to calculate ultimate bending moment and shear force for continuous beam, the F that appear in that table that we should use, the F is total load plus total load, and it is in kilonewton. So the total load here means, because this table 3.5 is applicable only if the beam, continuous beam, carry uniformly distributed load. So this total load, it should be the uniformly distributed load multiplied with the effective length. So this is in kilonewton per meter, this is meter, so the total become kilonewton. So if you overlook this, make mistake, you just take this W, then your design shear force, your design bending moment will be all very small. Will be all very small because you use the wrong F. The F in that table 3.5, this is for getting the coefficients to be multiplied with F to get the shear force and bending moment that you should design for, depending on where is the span. This one I will come back again when I refer to that table. So it should be total load, which is W multiplied with F, with L here. Now this is effective span. So if the questions does not specifically give you enough information to calculate effective span, you can assume that span given as effective span. Okay? So this is another point that you have to be clear about. So those are some of the important points. The next, I want to go to steps in the design of beam. Okay?